By 2050, nearly 70% of the world's population will live in urban areas, an increase of 55% today. There will be unparalleled demand for meaningful energy efficiency in buildings. However, many of today's buildings rely on HVAC systems that were oversized on installation to address uncertainty in the cooling and heating loads. Unfortunately, many building occupants still experience discomfort even with the extra capacity in HVAC systems. To make matters worse, most HVAC systems end up operating inefficiently, and this poor performance goes unnoticed by building owners and operators. In the US alone, poor performance in HVAC systems results in the unnecessary consumption of over $10 billion worth of energy. Much of this poor performance is caused by degradation or drift in operating efficiency. Degradation that is too gradual to be noticed in traditional systems and therefore goes unaddressed. Without automated maintenance alerts and regular recommissioning, most buildings will experience a drift in HVAC performance efficiency of 10 to 30% in just 2 years. Addressing and preventing this performance degradation is crucial to maintaining operating efficiencies, occupant comfort, and cost controls. Addressing this is more than just a cost control challenge, it's a sustainability issue. Buildings are responsible for over 39% of energy-related greenhouse gas emissions. Solving this will push building managers to change the way they collect and process HVAC operating data, because even though buildings everywhere are operating below their optimal efficiency, most building operators either lack the tools to understand the data that they receive, or worse, don't get the data needed to really understand their HVAC system. Armstrong uses a unique approach to help building operators improve efficiencies and save money. In the same way that a strong heart and good circulation of blood are key measures of health in the human body, the flow rates in an HVAC system are an important indicator of how well that system is functioning. If you recall a recent annual checkup, your doctor likely measured your pulse and your blood pressure and then listened to your heart. Just those few measures are a strong indicator of your overall health, especially when viewed in comparison to values recorded in your previous annual checkups. An increase in heart rate could indicate excessive exertion. A significant decrease in heart rate could indicate weakness. Increased blood pressure might indicate stress. Decreased blood pressure could indicate illness. Just like the human body, the flow rates in your HVAC system tells us how well it's operating and where the problems are. Without information on system flow, it's difficult to diagnose and optimize performance. With accurate flow information, the picture changes entirely. In any chilled water system, knowing the cooling load is the starting point. Cooling load in a building can be calculated by multiplying the system flow rate by the change in temperature, usually expressed as delta T. Traditionally, HVAC systems in buildings were designed only to meet temperature set points. Among other differences, this avoided the expense of a flow meter, which is important because the addition of a flow meter also adds extra piping, extra maintenance, and additional points to program and commission into a building automation system. But this design approach reveals a weakness. The building operator is often unable to identify progressive degradation hidden in the HVAC system. Without a flow meter installed, issues are identified only if the temperature set points in the system cannot be maintained. By then, it's too late, and after months of inefficient operations that could have provided a warning signal, occupant discomfort becomes a problem. Accurate flow meters are rarely in place in HVAC systems and are almost never installed on all of the circuits necessary to calculate heat balance. Particularly in a cooling tower or condenser circuit where water circulates between the chiller and the cooling tower, the efficiency of heat rejection is rarely known or even tracked. Even for those rare cases where a flow meter was installed, if it is not maintained and recalibrated, flow data becomes unreliable. As a result of this low accuracy, undetected system performance drift is common. In the circuit, changes in flow rate that can't be explained by demand may indicate clogging, leakage, changes in settings, or valve malfunction. Flow data gives us new abilities for diagnostics. It provides clues for new optimization approaches. It gives us more data for performance commitments and condition-based maintenance. Flow data can provide valuable insights at every stage of your building's life cycle and can have a direct impact on occupant comfort, energy savings, and equipment availability. Accurate flow data from both sides of a heat transfer device enables a clear assessment of an HVAC system, long before restrictions in flow cause problems in performance and occupant comfort. Understanding flow and changes in flow rates is a key first step in building a true load profile of a chiller and the heat rejection process equipment in an open circuit or a closed circuit. Using the flow data alone, we can diagnose a clog or decrease cooling tower function. With the addition of readily available temperature data, we can begin a process of optimizing the entire cooling system. Design envelope pumps provide flow data accuracy within 5% of the reading. Armstrong provides a host of higher-level solutions that leverage that accurate flow data to optimize system performance and detect degradation. These solutions provide performance persistence and support efficiency through their own continuous improvement processes. We refer to these as our active performance management solutions. Active performance management relies on analytics that are made possible by flow data and heat balance models of a system. The patented technology includes machine learning that is enabled through the flow information and made available from the pump at no extra cost. Active performance management services deliver system-wide HVAC efficiency for better building performance, lower operating costs, and lower maintenance costs. You can reach your sustainability goals, improve occupant comfort, attract discerning tenants, and achieve better business results through informed investment decisions. But it all starts with an understanding that flow informs.